So the problem says, consider the quadratic function y equals x squared minus 4x minus 12. We're going to rewrite the equation in factored form. Then we're going to see where our x-intercepts are. We're going to find the coordinate of the vertex, and we're going to graph it. So first, let's write it in factored form. I've got a trinomial. It's not a difference of perfect squares. There's no GCF. There's nothing in common to all three. So I'm just going to factor this with two binomials. I'm going to start filling them in by breaking up x squared, which is x times x. I'm now going to break up my 12, and my inners and outers will give me my middle term. So let's first talk about 12. The factors of 12 could be 1 times 12, 2 times 6, 3 times 4. There are no other numbers in between 3 and 4, so I'm done. Now what I need to do is I need to come up with which one of these sets can possibly give me a 4 if I add or subtract them, can give me a negative 4 if I add or subtract them. Well, I can't get that from 1 and 12. I can get that from 2 and 6. Not from 3 and 4, so 2 and 6 looks like that can work. So I'm going to say 2 and 6. I can do that because my x's don't have anything in front of them. So my inners are simply going to be 2 times x, so 2 is the coefficient, and 6 times x, so 6 is the coefficient. Now I need to know what signs are going to make this work. So I need these to get signs that multiply to give me negative 12, but the inners and outers will add to negative 4. Well, adding them is going to give me 8. So I know it's not adding, which means it has to be subtraction. So that means one of them has to be negative and one of them has to be positive. Since the x in the middle is negative 4x, that means the larger one should be negative. And this one should be positive. Negative 6 and positive 2, so negative 6x and positive 2x do make negative 4x. So that looks like that works. Inners came from positive. Outers came from negative. Let's check to make sure this last one is right. 2 times negative 6 is negative 12. Inners and outers add up to the middle. This looks right. So those are my factors. They then asked me to find my x-intercepts. Well, we know that on a graph, anywhere where you cross the x-axis, y is not positive, it's not negative, it's 0. Y equals 0 on the x-axis, right? On the x-axis, y is always 0 because it's not positive, it's not negative, y is 0 on the x-axis. So to find places where I cross the x-axis, x-intercepts, y has to be 0. So in order to find x-intercepts, I make y equals 0. Well, now that's easy to solve. I've got the zero product property, which tells us that when something times something else, when something times something else equals 0, one of them has to be 0. So I'm going to say, well, what happens when x plus 2 equals 0? And what will make x minus 6 equals 0? Those are going to be my two possible solutions. So I'm going to say I'm going to say x plus 2 equals 0. I'm going to isolate x by getting rid of 2. It's positive, so I minus. This goes away. I'm left with x equals negative 2. I add to get rid of the negative 6. This goes away. I got x equals negative 6. Those, sorry, I'm tripping. There we go. Plus 6, x equals positive 6. Those are my two x-intercepts. So now it wants the coordinate of the vertex. Okay, well, let's talk about what we have so far. We have a graph that has -2 as an x-intercept, and 1, 2, let's make that neater. Doesn't have to be beautiful, but it should at least be somewhat straight. That's not straight at all. Okay. So we have a graph that has -2 as an x-intercept. 1, 2, 3, 4, 5, 6. 6 as an x-intercept. Yeah? We know that if I have a parabola, the vertex is always going to be in the middle. I don't care what the graph looks like. If it's a parabola, the vertex is always going to be in the middle. Right? And the place where I cross will be equidistant from either side of that. My roots are always going to be the same distance away from the center. So wherever the vertex is, the roots are the same distance from it. So if I have -2 and 6, where's the middle where my vertex would be? I can count to see what the middle is, or I can just find the middle of two numbers, -2 and 6. And the way I find the middle of just two numbers is by finding the average of those two numbers. So I'm going to take -2 and 6, I'm going to add them, and then divide by the number of things I'm adding, which is 2. That's how I find average. So the middle of two numbers is always going to be the average of those two numbers. -2 plus 6 is 4. Divide that by 2 is 2. So 2 is going to be the middle of my parabola. So 2 is the middle, and that makes sense if we look at it. This is 1, 2, 3, 4 steps over here, and 1, 2, 3, 4 steps over there. So 2 is in the middle, right? Okay, but they didn't ask us for the axis of symmetry. They wanted the coordinates of the vertex. Well, I just found the x coordinate. Now I need to know the y coordinate. So x equals 2. I now need the y coordinate. Well, whenever I know x and I want to know y, I just plug in. So y equals, everywhere I see an x, I plug in 2 squared plus, minus 4 times 2 minus 12. This is 4 minus 8 minus 12. We don't have to do this in our head. We can use our calculator. -4 minus 12, -16. So I know that down here at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, obviously not very to scale, just a sketch. At 2, -16, this is where my vertex is. So my parabola is going to swing up through 6, swing up through -2, and there's the sketch of our graph. Not the prettiest parabola, but the math is all right.